Hi there, Calculus 3 students. So this is Mr. Lewitt again, making another tutorial video for you. Um, I don't want these videos to get extremely long because the longer they are, the more difficult they are to make and the longer it takes to upload them to YouTube. Okay, so let's say a half hour and that's about it. Um, so I have Mathematica here. I'm looking at your second homework assignment, dot product and cross product. That's still part of chapter 11, but it's going deeper into chapter 11. And I shouldn't have to say this, but I'm going to say this anyway. Remember, this is an asynchronous online course. Okay, this is not the best way to learn for all students. Some students really need a lot of extra support, not only from their instructors, but also from other classmates. You know, I've been teaching a long time now, and so what I often see is students will help each other out if they don't understand the professor. Um, this is very common. I've seen this many times. Students, one student will turn to the other student and ask him or her, "Did you understand what Mr. Lewitt was talking about? I didn't get it. Could you please explain it to me?" And, sometimes students learn better from each other than they do from the teacher. Um, so obviously, we're not meeting in a regular classroom anymore. So that opportunity, that learning opportunity has been taken away from you, which is unfortunate. Also, this is an asynchronous class, which means that we do not meet regularly for lectures. The best I can do is upload tutorial videos for you to watch. But honestly, guys, I can't spend my entire day making and uploading videos. I can do a couple of these a week, but I have two other classes to teach. And in addition, of course, family obligations. So I cannot spend my entire day making, educational lecture videos. So what that basically means is you are going to have to take responsibility for your own education. You have to stay on top of the homework, and yes, you actually have to read the textbook. Okay, I cannot emphasize that enough. I cannot do every single homework problem for you. I can show you how to do some of them, but I can't show you all of them. I mean, a lot of this is on you, and you really have to take responsibility this semester for your own education. Um, so it is what it is. It's a bad situation because of the pandemic. I understand, but like I said, guys, I cannot spend my entire day making these videos. I can do a couple of a week for each class that I teach, and that's my limit. Okay, and you guys have to try to respect that. What you should do, and very few of you have been doing it, if you are really stuck on one or two problems, okay, I don't mean 50 problems, but one or two, email me and ask me for some assistance, and I can email you back and try to coach you through the problem. Please don't tell me you need help with 100 problems or 50 problems. That's going to be a little bit too much. But if you ask me for help with one or two problems, that's fine, and then I can organize a Mathematica notebook and I can email that back to you for you to look at. Okay, so just a heads up on what my limitations and expectations are for this semester. Okay, so let's get started, and I'm going to do some homework problems for you from the second assignment. Um, I want you to really pay attention to this. You're going to have to take notes. You may have to pause the video, replay the video. You may have to watch the video like 10 times before you totally get it. And I really want you to read the textbook, because if you don't read the textbook, then, and if you don't practice the problems, and if you don't practice using Mathematica, I don't think this video is going to help you anyway. So you still have to do the work, right? I can't do it for you. Okay, I'm going to go into We have 150 problems here. So I'm going to go into one of the problems in the teens. I believe it's question 14. Yeah, this is a good example, okay? So we have two vectors. We have vector u is equal to -1, 2, or -1 comma 2. So that's -1 in the x direction and 2 in the y direction. And then we have vector v, which is -4 in the x direction and 4, or +4 in the y direction. So what we're looking for here is the projection of u in the direction of v. So you have to read this question very carefully. Let me turn on my magnifier. Here, let me turn that off 1 second. Okay, that was weird. Okay, there we go. Let me turn on the magnifier. So this time, okay, it's working. Okay, so these are my two vectors. Vector u is equal to -1 comma 2. Vector v is -4 comma 4. Calculate the projection of vector u in the direction of v. That's exactly how you read this. Okay, projection, the projection of u in the direction of v. So let me draw that. I'm going to use a drawing tool. It's not the greatest, but I mean, you should get the general idea. So let's say I have two vectors u and v. Let's see. Okay, this is going to be vector u. Okay. And this is going to be vector v. Okay? And I'm going to label this. So this is vector u. Okay, I'm trying to write as carefully as possible. And this is vector v. Okay? And what I'm looking for is the projection of u in the direction of v. So let me draw that with a blue arrow. Maybe that'll make more sense. Here, 1 second. There we go. Let me change colors. I'm going to make that blue. It looks more like turquoise, right? Oh, hold on 1 second. It's not, it's not quite what I wanted here. Okay, there we go. Okay, so the projection of u, the projection of vector u in the direction of vector v is going to be this vector right over here. The vector in blue, the arrow in blue. Okay, so how am I supposed to figure that out? Well, go back to your high school trigonometry. Go back to your high school trigonometry and pretend that these are triangles. Pretend there's a line over here and I have a triangle, right? So if that's the case, here, you know what? Let me change back to red 1 second. Okay, so if this was a trigonometry problem from high school, I would have the magnitude of u. Remember, u is a vector. A vector has magnitude and direction. I'm not interested in the direction right now, only the length or the magnitude of the vector. So the magnitude of u multiplied by the cosine of the angle. Okay, that's supposed to be, didn't quite draw that correctly, but this is supposed to be a theta, the cosine of theta. This is theta right over here. Theta, this is theta, which is the angle between vectors u and v. Okay, and that's going to give me the magnitude of this vector, and then I have to multiply it by the unit vector v. So how do you find the unit vector of v? You take v and you divide that by its magnitude. Okay, so let's think about this carefully. What is the cosine of the angle theta? The cosine of the angle theta, we know from reading the textbook, which I expect you guys to do, we know that cosine of theta is equal to U dot product V divided by the magnitude of U multiplied by the magnitude of V. Okay? And then we have to take all of this and finally multiply it by a unit vector that points in the same direction as the vector V. And that's going to be V divided by the magnitude of V. Okay, but we can also see that there's some simplification we can do here. So let me see. It looks like the magnitude of U here cancels out this magnitude. So what we're actually left with is the dot product of U and V divided by the, we can actually put this V, this magnitude of V right over here. Okay, we can actually take, we can put this magnitude of V and put it over into the denominator of the adjacent fraction, or the adjacent expression. So here, let me turn off the writing tool 1 second over here. Okay, so this is going to look a little weird because I'm actually typing right over what I just drew, but you guys can figure it out, I hope. So what I actually have is vector U is equal to -1, 2. Oh, so now I'm typing into the Mathematica program, right? And then vector V is equal to -4, 4. Okay, and I'm just going to follow my formula. I'm just going to follow the formula that I wrote down here, although it looks a little messy, but I think you guys can read it. All right, so I'm going to have dot product of U and V divided by the norm of V, 2 times the norm of V, 2. Okay, and actually that turns out to be the same thing as the dot product of V and V, or the dot V dotted with itself, and then I'm going to multiply that by vector V. Okay, so the projection of vector U in the direction of V will have an x component, as you can see from my screen. It will have an x component of -3 divided by 2 and +3 divided by 2. So -3 divided by 2 in the x direction, and then 3 divided by 2 in the y direction. Let's see if Pearson agrees with me. I hope so. Yes, so that is the correct answer, as we can see. Pearson graded my homework problem, and yes, I did it correctly. So I'm leading you guys in the right direction. I would be embarrassed if this was the wrong answer. Hey, occasionally, I make mistakes too. We all make mistakes. Now, oh, okay, we're not done with the problem. So Pearson wants to know, what is the scalar component of that vector? Well, that's actually pretty easy. So what I can do here, you know what? Let me erase what I wrote because my screen is getting extremely messy. To find the scalar component, I have two choices. I can do square root, excuse me, -3/2 squared plus 3/2 squared. And that's going to equal 3 over the square root of 2, okay? Or I could also use the norm command, the norm. Oh, first I would have to say, well, that's okay. I'll do it like this. The norm of -3/2, 3/2. And of course, I'm taking the 2 norm. I need to supply the argument of 2. And that's going to be 3 divided by the square root of 2. Now, Pearson is not going to like this answer. And I'm going to show you why. It is actually the right answer, but Pearson will not like this answer. And I'm going to tell you why in a moment. So if I type in 3 divided by the square root of 2, Pearson's going to complain. Check answer. We're going to click on check answer. Oh, I'm really surprised. Pearson did accept the answer. Okay, normally Pearson does not want you to enter an answer that has a radical in the denominator. Okay, let me say that again because this is important. Normally, when you're doing these problems, Pearson will not accept your answer if you have a radical expression in the denominator of your fraction. So therefore, you would have to multiply the numerator and denominator by the square root of 2 in order to rationalize your expression. So you would end up with 3 times the square root of 2 divided by 2, which is the same thing as 3 divided by the square root of 2. Okay, let's do another one of these problems. Let's actually do something, well, we're going to do one more problem. I don't want to do one that's too easy or one that's too hard. Okay, what would be a good compromise? Okay, this is very similar except for this problem, problem 15, we're in 3-dimensional space instead of 2-dimensional space. It's exactly the same thing. It really is exactly the same thing. And you're going to use the exact same formula. Let's try one of the orthogonality problems because it really is the next step. Hold on 1 second. Okay, we can do this one. This one's a little bit tricky. We're going to do, let's look at problem number 22. So this one is definitely tricky. This will be our last problem for this video, okay? Problem 22 in your second homework assignment. So let A and B be real numbers. Find all vectors to AB, so that'll be our vector u, orthogonal to the vector 8, negative 6, 7. Orthogonal means perpendicular, so it forms a 90-degree angle. Well, an orthogonality also means that the dot product is going to be 0. So if I have two vectors, you'll see in a few moments what I'm talking about, but one of the most important theorems in this course is that if two vectors are orthogonal, if they are mutually orthogonal, that means that the dot product must be 0. In fact, that's a way that you would test for the orthogonality of two vectors. If the dot product is 0, you know that the vectors have to be orthogonal. They are perpendicular to each other. Okay, so let's take a look at this. What are all the vectors that are orthogonal to 8, negative 6, 7? Select the correct choice below, and if necessary, fill in any answer boxes with your choice. So this problem is a little on the tricky side. So I'm going to do some drawing again. Let me, first of all, let me just store this information in Mathematica. So my u vector is 2ab, and my v vector is 8, negative 6, and 7. Okay, terrific. So I have that information. I can cover up the problem now because I do need some space for drawing, okay? Okay, let's do some drawing just like last time. And let's see. I'm going to draw my red arrows. So this is going to be vector u, and this is another red arrow. This is going to be vector v. All right, so let me label my arrows. So let's see, this is going to be vector u, and this is going to be vector v. Okay, fantastic. And just like last time, how do we figure this out? So let's go through this again. We have u. Well, it's actually, sorry, it's the magnitude of u. It's not just u, it's the magnitude of u multiplied by the cosine of theta, and that's going to give us the magnitude of the projection of vector u in the direction of v. Okay, so let me change colors here. We're going to change colors. Okay, 1 second. There we go. And let me draw another arrow. So what I just figured out here, the magnitude of u times the cosine of theta, this is going to be equal to the length or the magnitude of u in the direction of vector v. Okay? But again, what is the cosine of theta? And you just have to memorize this particular formula because it shows up so often in this course. The cosine of theta is the same thing. Oh, wait a minute. The cosine of theta, that's supposed to be a u, by the way. The cosine of theta is the same as the dot product of u and v divided by the magnitude of v, the magnitude of u, that's supposed to be a u, and the magnitude of v. But that only gives me the magnitude of the vector. If I want the vector itself, I have to multiply this entire quantity by a unit vector that points in the same direction of the vector v. So again, just like last time, vector v divided by the magnitude of vector v. Okay, so let's actually, here 1 second, let me turn this off. Okay, so let's actually do this in Mathematica program, okay? So we're going to have, I'm going to call it W. W is going to be the norm of u, the 2 norm, multiplied by, now remember in Mathematica, guys, you have a choice. You can use the star to represent multiplication, or you can just use a regular space. Okay, a regular space, that's the same thing as multiplication. Dot product uv, control divide by, makes it look pretty like in a textbook. The norm of u times the norm of v. And we're going to multiply that by v divided by the norm of v. Shift enter. Okay. Now the problem is we're looking for a vector that is orthogonal to v. Hold on 1 second. Let me look at the problem again. Yeah, we're looking for a vector that is orthogonal to v. So if we want a vector that is orthogonal to v, let me just change colors here. If we want a vector that is orthogonal to v, we really want this vector right over here. Okay, well, how do I get that vector? Well, that should be easy. I'm simply going to take the original vector u minus w. This is going to be vector u minus w. Let me write that down. This is vector u minus w. And actually, in this case, you could even do w minus u, and that's still going to be perpendicular. It'll just point in the opposite direction. But this is vector u minus w. Okay. So then, what should I call it? My final vector, I'll call it z, call it whatever you want to call it, is going to be u minus w. U minus w. Now, the problem is here, we need to figure out values for a and b, and this can get a little bit tricky. This can definitely get a little bit tricky. This is the right answer, okay, but we need to find values for a and b. So I know if I do the dot product of z and v, and let me expand this. That's going to be 0 because the vectors are indeed perpendicular. The vectors are indeed perpendicular, but I need to find values for A and B. I need to find values for A and B. Hold on 1 second. Let me just take a quick look at this. Here, let me erase. You know what? Let me erase. Hold on 1 second. There we go. Okay, so this problem, actually, I went a little farther than, you know what? I went a little farther than necessary. So my z vector is correct. My z vector is correct. This works, but the problem is here, I went a little bit too far. I don't think they wanted quite this much. So, okay, I went a little bit farther than necessary with the problem, but that's okay because still what you saw here was good, really good for you to know. So what they're looking for, let's go back to our original u vector and let's go back to our original v vector. What they're looking for is numbers a and b such that the dot product of u and v is going to be 0. So the dot product of u and v looks like that. That's the dot product of u and v. So it's simply 2 times x, which is 16, plus a times negative 6, which is negative 6a, plus b times 7, which is 7b. And that has to be equal to 0. So what I could do here, solve dot product of u and v is equal to 0. And the answer is going to have to be b. Vectors of the form 2. Okay, so we want b expressed in, Pearson's looking for b expressed in terms of a. And we can simplify that. Okay. So what they're looking for is a vector of the form 2, okay, a, and then b is being expressed in terms of a, and that's going to be 6a minus 16. Let me highlight this. 1 second. Okay, this is a little hard to highlight here. Highlight that, press the divide key, so 6a minus 16 divided by 7, and that's really all they're wanting. That's all they want. So I went a little bit farther than necessary, but that's okay. So any vector that has this form, 2, a is just a number, and then b is going to be 6a minus 16 divided by 7, any vector that has this form is going to be orthogonal to the vector 8, negative 6, 7. Okay, and it should be correct. Yeah, that's correct. Okay. And how do I know that's true? Well, here, hold on 1 second. So if I have, here, there we go. B is equal to B as it's defined on the previous line. Okay. So now vector u looks like that, and vector v looks like that. What is the dot product of u and v? Let's simplify this. It's 0. The dot product of u and v is equal to 0. So let's see if that's true. 2 times 8 plus negative 6 times a plus 7 times b, which is b is actually this expression right over here. 6a divided by 7 minus 16 over 7. Okay, and if you ask Mathematica to simplify the expression, which is a good idea, or we could do a full simplify, which is even better, the whole expression algebraically simplifies to 0, which means that the two vectors are indeed orthogonal. Okay, I realize this was a lot to cover, but you guys must read the textbook, and you must continue working on these problems. There's just no substitute for that. Okay? We will communicate soon, I hope. Take care. And let's see, we're done. Have a great day. Bye-bye.